All right, I just wanted to, real quick, jog your memory on these. I mean, this is what you should be doing for yourself, because you know what's coming. On Wednesday, I'm going to have the practice test, but I'm also going to have a worksheet you guys are going to work on together. And the first thing I'm going to ask you is just go through, don't even do any work, just identify what form everything's in. So, of course, one equation could be in 2 or 3 different forms, like we were saying before. So we're finally getting to that point. I talked about this before. One big thing about typic use is identifying what type it is. Because if you know what type it is, you know what to do to it. And if it's several types, you just go, well, what's normally the easiest type? Let me try that. So what is it? Separable, there's not much to say with separable. I mean, I feel completely comfortable just saying easy, depending on integrating method. Is that cool? Right. Depending on what you actually have to integrate and the method that you're required to use, that's still easy to kind of, you know how to attack it, is what I'm trying to, that's easy. You know how to attack it. Why could the actual work be hard? It could be some funky function, it could be trig sub, it could be biparts, it could be who knows what else. Right? What's the idea behind a linear equation? What's the idea? The fundamental idea behind a linear equation, you have to find something. What do you have to find for numbers? Can you write what a linear equation looks like? Just write down the general form of a linear equation right here in your notes. Write it down. I hear some flipping. I hear some flipping. That's all right. Now look at stop. Stop flipping through your notes. My God. You should try to challenge yourself before you go flipping back. So I mean, I'll accept a couple different answers here, depending on what stage it is. But the most general kind of look starts with the A. Yeah. So let's do linear. I could be a little more specific, I guess. First order. I hope you realize the higher order stuff you're gonna have to leave off for a little while. That's gonna come in the next part of the class this semester, because higher order stuff, you should realize it's gonna be a little bit harder. Plus y equals, and then here you have a choice. I can't remember, did I get the 0 and the 1 where I played the equals? All right, be a little more specific. Q of x, yeah. Or in the book sometimes put it as an F there for some reason. So this is a neat combination. So let's call it F, because where do I bring Q in when I divide by that coefficient, right? So another way I can take it is dy dx plus p of xy equals q of x. And the book sort of goes between those two, whatever. So now, maybe if you see the form of it, you remember what you're looking for a linear D. What is it you're looking for? What's it called?
Find u.
Yeah, find the little mu dude. Integrating factor, right? If only. Integrating factor, right? If only I knew how to do this. Oh yeah, integrating factor. So, I don't know, I just made that up. Is that any good? So this is where you're looking for the mu. And does anybody remember how to find the mu?
e to the derivative of px, or integral of px.
What's in there? Sorry?
Px.
P. I got you. I like it. I like it. So you got to divide, put it in this form so you can see what that P is in the first place. And then that's how you find the integrating factor. That's what you multiply everybody by. And then it becomes nice on one side and hopefully nice on the other side. Does that jog your memory? I mean, this is the kind of thing you want to do for yourself. What is it that I'm looking for? Separable? I'm not even going to write any notes up here. You can. That's the first thing you look for because that's the easiest way to attack something. Just straight up integration. Linear. Should be able to identify a linear D. If it's not separable, you might want to try to see if you can put it in this form so you can see what the integrating factor is. Right? What is it about exact? What's kind of the form of the exact one? I'll start us off. what's the check to see if it's exact? Partial of m with respect to the other thing. I like it. So that's a nice, easy way to remember. M's are already with the dx, so I've got to check the dy. If that equals partial of n with respect to x, then it's exact. And this is related to Clairaut's theorem, which is talking about if these are equal, they must be like cross partial derivatives, cross second partial derivatives. So then m itself must be some fx. N should be some fy, and then I can integrate backwards to figure out what f is. And it's got a very kind of recipe-ish way to do it. Find fx, integrate it, like partial integration with respect to x, so you get a g of y constant. I mean, if you've done the, well, if you haven't done the homework, it probably sounds like gibberish right now. You're like, dude, I did it. It still sounds like gibberish. But, I mean, once you've done a few of these, you start to get the feel. Now, I keep saying this, if you take a 281, this should be easy, because you should have done a decent amount of that in your 281. In fact, you should have done some even higher level shit related to this in the 281. Okay. So this is 22, 23, 24. Today we're going to talk about 25. 25 is all about forms that you can use substitution on. And they deal with, however you want to say this word, homogeneous or homogeneous, and Bernoulli's. Those are the two main types. Oh, poor Bernoulli. Those are the two types we're going to focus on today. And we've done substitution before. I want you to realize these are both a form of just U substitution. It's kind of nice. They're not going to feel as nice as U substitution, but it's a form of it. So let's take a look. Bernoulli's. Let's start with. No, sorry, that's not. That's right. Let's start with homogeneous. Bless you. So let me ask you, I mean, I really, really kind of dislike the way this book does homogeneous, right? It does some other stuff really well. This one, it just, good Lord. And I don't know if this is the way that DiffyQ books do it nowadays, to be honest. But let me show you the idea, and then if you read through the book, you can see how it sort of relates. They just make it a little harder than it really needs to be. Basically, remember, I have they're partial. If f of xy can be written as a function of y over x, then it's homogeneous. We'll call it homog. Somebody's going to figure out. Okay. So let's see an example of this. What do I mean by a function of y over x? So we got the one from here. No. You want to look at it some more? It's okay. Okay. Or are you trying to say I didn't want any of that? All right. So here's an example of a function that I'm talking about. So a lot of these things can actually be done. I'm going to show you the way to look at it that I was taught, the way I look at it, and then I'll try to bring in the book's perspective. What I'm about to say isn't perfect, but it does work on some of these. Do you notice how every term is at the same degree? If you remember what degree means, it's just the number of letters. 2 x's, 2 y's, 2 x's, an x and a y. So they're all degree 2. Okay. Now it's a little more than that, but that's kind of like what I look for real quick to even try to see if it's homogeneous, right? So this one is the one I remember, and this is the one that's easier to kind of work with. Remember how it works. Can you get this to be a function of y over x? What the hell would that even mean? So a function of y over x would be like y over x plus 2. Right? That's a function of y over x. So how would I start to make ratios of y's and x's? Well, I could just do what to both sides? What could I do to start making ratios of y's over x's? Divide by x's, right? How many x's do you think you should divide by?
2.
Yeah. All right, so if I divide everything by x squared, both sides, yay, I'll get 1 plus y over x, got it, squared, plus 1 minus, one of these x's cancels, y over x equals 0. Let me just stop there. Just understand that by itself. Right? This idea of, can you recast this? So what we're really doing is we're figuring out what to do our u sub on. Right? And homogeneous is really all about letting u be y over x. And when will that work? When I can actually make nothing but y over x. Is there any rogue y or x terms? No. If this was an x, I couldn't do homogeneous. Because then it's not a function of y over x alone. It's a function of x and y over, oh shit. But there's no rogue y over x terms. I lost my poor little dy. You guys are freaking out about that. Sorry, just forgot to write it. He was traveling then. So the way the book describes it, they only mention this y over x idea very briefly. And if you don't really read through all the extra shit, you're not going to even see it. And to me, that's the most important thing. The way it's taught in the book is they just say, let y equal ux. And it's a really good question. Why the shit would y be some multiple of x? Why would I expect that? Well, no, if you cast the whole thing in terms of, can you write everything in terms of y over x, then that makes complete sense. Because now I'm just going to let u be y over frickin' x. But if I were to teach this and say this, here's how the book presents this. It doesn't say a damn thing about y over x. But notice, if I replace x with tx and y with ty, everywhere, don't all the t's cancel? And that is the same thing as what I said about they're all in the same degree. You guys see that? This would be t squared x squared, t squared y squared, t squared x squared, t squared xy. I could divide everything by t squared, it's the same stupid thing. So if replacing x with tx and y with ty leaves it alone, then it's homogeneous. That's the way the book introduces it. And then it just goes to say, well, if that's true, you do this. And if I'm a student, I'm like, why the shit would I expect y to be some functional multiple of x? Do you guys see that? All right, so that's, if you don't, then that's fine, because it's not even a problem that's going to happen now, because now it just makes complete sense. What would I substitute for? Y over frickin' x.
U.
Yeah, going to make u y over x. Whatever y divided by x is, it's a function of x. Y is a function of x. X is x. All right, so u is y over x. Now what else do I have to be careful about when I say u is y over x? Well, what's dy?
Partial derivative.
No. dy will be u dx plus you do it. X du. And I think the book, what form did they put this in? Oh, actually, yeah, they have it right there. Yeah, of course they do, because they have the y equals ux, so it's easy for them to make the next step. But if you skip the u equals y over x idea, the whole thing kind of falls apart a little bit. about why I would even do this substitution. Hopefully that makes some sense. This looks disgusting as hell from a standpoint of y and x, because you got this ratio. Holy shit, what the hell? It's not linear. What? Right? You guys with me? I mean, it's just gross. But the minute you replace this with u, and why can I do that? Well, because y over x is a function of x. Let me call it u. Of course I can do that. We've known that since algebra. I don't know what that is. Let me call it something. So what does our equation become now? This part's easy, because dx is dx. Gotta love that shit. So 1 plus u squared plus, now here's the part that you just have to deal with. Too bad. You know there's going to be a trade-off here. We've got a FOIL. Ooh, right. This will be 1 minus u. And then dy is u dx plus x d. Now before I get too far, let me see, we're obviously not done with this, right? Couldn't I have divided everything by y squared? And normally if you do that, you're going to use x equals vy, just to make a distinction. Everything's the same. Do you guys understand this? Everything's the frickin' same, except now dy stays the same. We're thinking of x as some function of y. Do you guys see that? Because again, we should be very familiar, very comfortable with the fact that x and y aren't special anyway. One could be the other one, it doesn't matter, right? So there is, and actually while I have this up here, all right, so you could do another option. So on one level, it's kind of like, well, why don't I just always do this, Jeff? All right, I love that idea. Except when do we do this? We do this when the m is easier, and we do this when the n is easier. In this case, they were like on the same level. I wouldn't say that one of these is better or looking function than the other one. You guys with me? Okay. Let me make sure I said that the right way around. Blah, blah, blah. Yeah. That's how I remember it. I was trying to remember if that was correct. Use this one if m is good because it's the part with x. If n is better, it's with y, so I'd use this one. That's the only reason that I would even say that there's two options, right? Because on one level, it's kind of like they both do the same thing, Jeff. All right. Maybe. So let's keep going with this. So here I got 1 plus u squared dx plus, just distribute u dx plus x du minus u squared dx minus xu du equals 0. Get rid of this. We don't need this here for right now. And now just collect your dx and your dy terms. Right. So we get, this is nice, minus u squared plus u squared. So now I get 1 plus u dx plus x minus xu du equals 0. Can we stop there for a second? The secret to all the math is that 60% of almost any problem is algebra. So the people that die in higher level courses are people that don't really get their algebra. And you're all like, dude, stop talking about it. I remember I had a teacher, he wouldn't finish the damn problem. I said, the rest is algebra. And there would be students going, please, can you just finish that, please? Now, what you would hope for is that this substitution would make it easier somehow. Can you guys see what kind of thing this is? Let me help you out. So 1 plus u dx plus x times 1 minus u du equals 0. This is it exact? Yeah. Well, let's see. Partial with respect to u is 1. Partial with respect to x is negative u. 1 minus u, right? So not quite. It's not exact. But it is. What do you always start? What's the first thing you check? Separable. Is it separable? Yes. All right. So try to finish that out. Let's see what you can 1 over s dx plus, I just put it on the other side, so I guess, equals u minus 1 or u plus 1. U, is that cool? Subtract it so these flip. And when you separate, you can actually have everything on one side. Because you can integrate both pieces, but it's kind of silly to do that. Just take a look. What do you got on this side? That's right, Jeff.
The other way around.
Is it?
Over.
No. Because you're going to subtract that over, and then you're going to divide by 1 plus u. Yeah. When I subtract that, I just flip those around. How do you integrate that other side? You can do one of two ways. You could actually do like an m substitution. You've got to call it m substitution because it's already freaking u. Or you could do, come on, give me some ideas here. Anybody have any idea how to do that one? Let me give you one that's a little more obvious maybe. If I ask you to integrate this.
Oh, partial fraction.
No. Why not partial fractions? Because the bottom has only one part.
Separate u over u plus 1 minus 1 over u plus 1.
No. See, that won't help you either. See, because you can't cross anything out that way. The top's got to be more than one term. The bottom's got to be one term.
Integration by parts, can you just...
I love you guys so much. What? Put yourself into 176 for a second. What would I probably be asking you to do?
Can't you add the top and
multiply
you cancel it out?
How?
Factor.
Can you factor? Well, all right. In case you can't. You can't factor it by 5, can you? No. Long division.
Yeah.
Or synthetic division, if you like that. But look at this little thing. U plus 1 into u minus 1. I mean, something you got to realize is that something like that can happen any time. And this is, I know, I was looking at the survey responses a while back. And I love that. People are like, a lot of people said, I hate how teachers expect you to know every damn thing you've learned so far. Okay. On the other hand, if you look at everything as memorization, there ain't no way you're going to do that. But if you look at everything as understanding the idea behind something, then it's just going to make sense. It'll be easier to remember because it's just a part of why things make sense. And of course, that's not an easy thing to do, but that's what you're always trying to do if you want to be a really good student. So you do this, 1, 0 plus 1, change the signs, minus 2. So you go 1 minus 2 over u plus 1. Is that cool? Or you could do m is u plus 1, so u is m minus 1, so dm is du. I mean, is that... What's the idea here? If only the bottom was a single term. That would be so kick-ass, because then I could reduce things. So let me use substitution to force the bond to be a single term. I mean, that's another way to do it, but we've already done substitution once. I always hate doing multiple levels of substitution. Either way you do it, you get to this point. When you integrate it, what are you going to get?
211 plus 1.
You'll get u minus 2 ln of u plus 1. All right. Oh, there it is. Oh yeah, and then, just for things to be gross. You gotta bring back in, what is u?
What?
Yeah, y over x. And this is where you sort of give up on trying to solve for y. I mean, you could do a few little things, but not really much. I mean, you can multiply both sides by x, that'll make it a little bit, and then add this part over. You can't really get y really by itself, so you just sort of say, that's fine. I'm okay with that, right? So this is a nice implicit solution to this. Okay, maybe.
Is it separable? We just leave it like that.
Some separable is going to come out like this.
We can do it.
Just because it's going to be so tangled, it's going to be an implicit solution. Let me give you one to try on your own. So do this one. Let me see. And I will be collecting these and grading them partially. No, I won't. So that means just try whatever the hell you can. I'm not going to look at these, so. All right, so use the method we just talked about to solve that. going to lead to a possibly gross interval. Either some of you guys might have it memorized, some of you guys might have to use trig solid. Try to start catching up to you guys. What did you divide by? X squared. And the general rule, the n's easier, so I'm going to use y equals ux. It's kind of like a deal about which option. Even if you did x equals vy, it would still work. It's just going to be a little bit worse. More than likely. So then I end up with y over x plus y over x squared plus 1 minus dy. And we used y equals ux, yux. So then we get dy is udx x du. I like it. So then now I can rewrite this as u squared minus udx minus x du. Negative distributes. And then you real quick you just look for, here's your u dx and another u dx. It's this opposite sign. That's sweet. So then you end up with u squared plus 1 dx equals x du. So notice what this substitution seems to do, and then I'll tell you that it always does. If you make the substitution, if it's Bernoulli's, you make the substitution, it becomes separable, which kicks so much ass. Not Bernoulli. Did I say Bernoulli? Homogeneous. I definitely want to get to Bernoulli's because it's kind of nifty. So if it's homogeneous, I mean you can make one of those substitutions for y over x or x over y. Once you do it, it becomes separable. So now you get integral dx over x equals integral du, and here's the one I was talking about. So let's see. Let's just do a quick jot down memory lane here. How do you do stuff on this? In case you don't know what that interval is. Oh, let's see. Let u equal. See, I always love this. It's not going to be sine or cosine because sine or cosine will be 1 minus something squared. That's the identity related to them. Tangent. Tangent squared plus 1 is an identity. Yeah, exactly. So that's, I never understood students that had trouble with this unless they didn't know their freaking identities. If you know your identities, you know exactly which trig sub to use. Because it's the trig sub that's related to one of the identities you want to use. Alright. So let u equal tangent theta. So then du is secant squared, like you guys already said. I'll do this side. Yay, Jeff. Yeah, you get integral. Du is secant squared, theta d theta, and u squared plus 1, of course, is going to be secant squared d theta. And this is awesome, right? So you get natural log of x plus c equals integral of 1 d theta is theta, and theta is Inverse tangent, I like it. Or arctangent if you enjoy writing more letters. So that means, put it, natural log of x plus c equals arctangent of u, and u was
Y over X.
y over x. And then you can take the tangent of both sides, multiply the x up. Do you guys see that? You could actually solve this for y. Take the tangent of both sides. So this whole thing will be inside the tangent, and then multiply the x up. So you get x tangent of this equals y. That one you can solve for y. Y is just in one place. You can uncover that. I like it. So, any questions on this problem? Yes.
Could you have solved it by dividing by y squared? Or do you have to-
Yes. You could have solved. You could have done by y squared, and then you would have said x equals dy. It would have been a little bit worse, and really the little bit worse part comes from that would have been something, and you would have had to. It's got more terms to distribute. Yeah. Okay, but it would still work totally. So you just do what you think of and just plow through it. It would still work. So a couple quick words before I let you out of here on Bernoulli's. It's powerful. Oh, high order. It makes math make more sense if you're just a little high.
Preferably, but
Well, then, whatever method you like. So watch this form of this. It looks very familiar so far, right? So far, it looks really familiar. Right, and then there's a little bit of a, and I love this book, so I'm just going to do what they do. Ah, shit. Right. So Bernoulli did all, oh my God, if you're going into any kind of structural or fluid mechanics or anything, Bernoulli's going to come up. Oh my God, this dude did too much. It's like, give me your workup, dude. If only what was true about n, this would be what? There's a lot of blanks in that sentence, and I don't care. If n was 1 or 0, this would be linear. You guys see that? This would be linear if n was 1 or 0. So Bernoulli said, okay, what if it's not 1 or 0? What can I do to make it linear? There's a substitution I can make to make it linear. So the substitution I can make is let u equal to y to the 1 minus n. Kind of freaky. So see how this kind of works first off, and I want to show you. Well, watch this. If I divide through by y to the n, what do I get? I get y to the negative n. Is that cool? What do you get here? Divide y to the first by y to the n. I get y to the 1 minus n. Huh, holy shit. Equals, yeah, whatever. So this shows you why that substitution makes sense. In order to be linear, I want this to be u. Or, I want it to be y, really, but y is taken, so I want it to be u. Then it looks like it might be linear. Then the question is, what the shit about that? Well, all right. If u is y to the 1 minus n, what's du? 1 minus n. Y to the negative n. Yes, I know, that's really sweet. And then you can, so then, I'm sorry, dx. So then I can make this, I know my y's and my u's. Then I can make this in terms of u, linear in terms of u. I'll make u this, because that's where I want the u to be for it to be linear, and thank God this becomes related to du over dx. What? You can work it out on your own, which is really what you should do. Right? Make sure I know what the hell I'm talking about. Who is this guy? I don't know. Could have just walked in, could have killed Jeff. No, you're all gonna be thinking about that. Let me see what else can I make up. So, let's see, do I have time? No, shit, alright. I won't kill you if I do an example. That's the last part of section 2.5 is Bernoulli. So instead of doing another quiz, we're going to do that group worksheet on Wednesday. And I'll have the practice test on Wednesday. I'll have an answer key for that on Monday. On Monday will be a review for the test that's happening, of course, next Wednesday. Correct. Yes.
Did you have your test last time?